let's take an example for this. Now here numerator degree is what? X square, and denominator degree is 1, 2, 3, 3. Okay. So degree of denominator is greater than degree of numerator. Okay. Now these are all linear. Okay. So we can apply, since it is linear and non-repeated, so we can apply. Therefore, this is same as a upon, you can say, therefore 5x square minus 1 upon x into x minus 1 x plus 1 is equals to a upon x plus b upon x minus 1 plus c upon x plus 1. Okay. Now here we can solve two ways. Okay, by comparing all the coefficients of x, means coefficient of x square, coefficient of x, and constant term, or substituting values of x. Here, if I substitute x equals to 1, so let's see, it implies multiplying whole this factor on this equation. Okay, whole this factor, multiplying these, okay, on this. So we have 5x square minus 1 equals to a into x gets cancelled. What we have is x minus 1 x plus 1 plus b, x minus 1 will get cancelled. We have b into x plus 1 plus c x plus 1 will get cancelled, c x into x minus 1. Okay. What I am doing is I am multiplying whole these into the both the equations. Okay, left hand side as well as right hand side. Okay, so if I this each and every term. Okay, now let's substitute when x equals to 1. Why I am substituting x equals to 1? If I substitute x equals to 1, then these two will get 0. Okay, and I will be getting the value of b. Okay. Therefore, if I x equals to 1, 5 into 1 square is 5 minus 1 is equals to, these two gets 0 because x 1 minus 1 is 0. Here 1 minus 1 is 0. b into 1, okay, into 1 plus 1 is 2. This implies 4. 5 minus 1 is 4 is equals to 2b. Therefore, b equals to 4 by 2 is 2. We are getting the value of b when we substitute values of x equals to 1. Okay. Similarly, if I substitute x equals to minus 1, okay, if I substitute x equals to minus 1, then this term and this term will get cancelled, and I will be getting values of c. Okay. So 5 into this minus 1 whole square is 1, so it doesn't have any effect. 5 minus 1 is same as 4. Okay, is same as I am putting x equals to minus 1. Okay, this term will get 0, this term will get 0. C into minus 1 is minus 2. It implies 4 equals to minus 1 plus twice c. It implies c equals to also 2. Okay, here I am having b equals to 2, c equals to 2. Okay, now if I substitute x equals to 0, okay, when x equals to 0, this term will get 0. Okay, 0 into anything is 0, 0 into anything is 0. So 5 into 0 square, this will get 0. I will have minus 1 equals to here a into minus 1 into plus 1. Okay, this implies minus 1 gets cancelled. Therefore, a is equals to 1. So I am having all values of a here. Okay, let's substitute. Okay, in equation number say 1. Okay, equation 1. If I substitute equals to 1, this integral is equals to integral a is what? What is a? A is 1 by x dx plus what is b? B is 2 upon x minus 1 dx plus c is 2 upon x plus 1 dx. Okay, It implies this is log of, what is log of x plus, if I differentiate this, you are getting this, so same as 2 of log of x minus 1 plus 2 of log of x plus 1 plus some constant of integration. Okay. Otherwise, what we can do is we can expand this and this. After that, we can compare the coefficient of x square on left hand side as well as right hand side. Okay, same answer we'll be getting. Okay. Now trick is, now consider here. Okay, now if I substitute x equals to 1, okay, x equals to 1 here. Welcome to the section of this course, integrations. There are some integrations we have to solve with the help of partial fractions. Okay, now I told you before, you have to check in order to solve the partial fractions. Okay, denominator, degree of denominator should be greater than degree of numerator. Okay, see, I have given 5 questions. Okay, in this part. So in all five questions, you can see over here, this is algebraic, here trigonometric. Okay, you can see in algebraic over here, in algebra also denominator is what, the degree of denominator is greater than degree of numerator. Here also degree is what, 1 2 3, here is 1. Okay, here also 2 1. Okay, in this, what we have to substitute, you have to bring into the algebraic form, and then we have to do partial fractions. Okay, now let's solve one integral of x square upon x minus 1 into x minus 2 x minus 3 dx. Now, since degree of this is what, 3, okay, now 3 is greater than 2, degree of numerator is 2. Now, all these are linear, okay, all these terms are linear as well as non-repeated. Therefore, this can be written as, therefore, x square upon x minus 1, x minus 2, x minus 3 can be written as some constant a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. After that, multiplying x minus 1, x minus 2, x minus 3 on both sides, we have, so if you multiply these on both sides, what we'll get over here, this term and this term will get cancelled. We'll have only what? We'll have only x square on the left hand side. On the right hand side, a here, x minus 1 and this x minus 1 will get cancelled. I will be having a into what? X minus 2 into x minus 3 plus, similarly b, x minus 2 will get cancelled. We'll have x minus 1 into x minus 3 plus c, x minus 3 will get cancelled. We'll have x minus 1 into x minus 2. Okay, now here our aim is what? To find all arbitrary constants a, b, c. Okay, our aim is to find all these arbitrary constants, this and this. Okay, now what we can do is, we can do by substituting or putting, means if I substitute x equals to 1, we'll get some constant, we'll get some values of b or c. Okay, similarly, if I can substitute x equals to 1, x equals to 2, as well as x equals to 3, or x equals to 0. Okay, if it is according to the scenario. Or what we can do, we can expand this, and we can compare various powers of x, such as x square. On the left hand side, we have x square. Here also we'll get x square. Here also we'll get x square. For example, if I compare the coefficient of x square, what will have here? The coefficient of x square is 1. Here I will be getting a into x square will get some constant. So a plus b plus c. Similarly, in that way also we can solve by comparing various powers of x. Okay, the best way to solve is by substituting. Okay, Let's see if I substitute. Say if I put x equals to 1, okay, on this equation, okay, on this equation, main equation is this, okay. If I substitute x equals to 1 on this equation, means left hand side as well as right hand side, okay. On the left hand side, what we have is 1 square is 1 is equals to x. Those terms which you have x minus 1 will get 0 because 1 minus 1 is 0, okay. Therefore, this and this term will get 0. What we will have is a into 1. I am substituting x equals to 1. Here 1 minus 2 is, we have minus 1, and here 1 minus 3 is minus 2. On the right hand side, on the left hand side, I have 1 square is same as, if you want you can write 1 square is same as 1, okay. This implies 1 equals to minus plus 1 into 2 is 2, okay. Here 2a. Therefore, a equals to 1 by 2, okay. Here we have the value of a, okay. What I am getting when I substitute x equals to 1 in this equation, I am getting a equals to half, okay. Similarly, if I substitute x equals to 2, why 2? Because see here you have constant term, arbitrary constant term, okay. Those polynomial which you have, like if it is, for example, if it is x plus 1, okay. So in order to get cancelled over here, you have to substitute x equals to, instead of 1, you have to put minus 1, okay. So similarly, why I am putting x equals to 2, because this term will get cancelled, okay. Those term which you are having x minus 2 will get cancelled. Here x equals to 2. Here 2 square, okay, is equals to those terms which you have x minus 2 will be 0. This term will be 0 as well as this term will be 0, okay. Now you have b. b into what? 2 minus 1 is 1. Here 2 minus 3 is minus 1. Is implies to 2 to the 4. Here minus b, okay. Here plus minus minus. Here b, okay. Therefore, b equals to minus 4. So you are getting, when you substitute x equals to 2, you are getting b equals to minus 4, okay. Similarly, if you substitute x equals to 3, okay, you will get the value of c. X equals to 3. Here 3 square, okay, 3 3 you can write 9 is equals to, or you can write for time being 3 square. This term will get 0. This term will get 0. C into 3 minus 1 is 2. Here 3 minus 2 is 1. Therefore, it implies 3 3 is 9 is equals to 2c. It implies c equals to 9 by 2. So now you have all arbitrary constants a, b and c, okay. Since the question is asking, you have to integrate this, okay. This instead of integrating this, so I already assigned a, b, c arbitrary constants. I already find all the constants exact value and substitute all these values over here and then integrate separately. Instead of integrating this is same as integrating this plus this, okay. Therefore integration of this is what? Therefore integration of this is integral of this is same as integral of what is a? A is half, okay. Here half upon x minus 1 dx plus what is b? B is minus 4. So I can write here, since it is constant, I can send outside. Here we have 1 upon x minus 2 dx plus what is c? C 9 by 2. 9 by 2 also constant. I can send outside. X minus 3 dx, okay. Now half. Now if you differentiate denominator, if you are getting numerator, then that is log. Remember, we have this integral of 1 by x dx equals to what? log of x plus some constant c. Why? Because what is differentiation of x? Differentiation of x is 1. Okay. If you differentiate x, if you differentiate denominator, if you are getting numerator, then that is exact numerator, exact. Then that is log of denominator. Okay. Log, what is denominator? You have x. Okay. Well, log of x is the formula. Okay. Therefore, what you have is, you have in denominator x minus 1. If you differentiate x minus 1, what you are getting? 1. Okay, therefore that is what? Log of x minus 1 minus 4. Similarly also here, if you differentiate x minus 2, you are getting 1. Okay, therefore that is log of x minus 3 plus 9 by 2. Similarly, log of x minus 3 plus c. Okay. This is the correct answer. Okay, this is somehow lengthy. What I am doing is, by this method is called substituting method. Okay, means we are substituting the values of x. Okay, all values of x. Okay. Now we have some tricks. Okay, we have some tricks for this. Now this trick is applicable only when keep in mind, all the terms are linear as well as non-repeated. Keep in mind. Okay, these tricks, okay, the tricks which I am going to explain, it should be what? It should be first, it should be what? Non-repeated. Number 2, it should be linear. Okay, non-repeated. Repeated means what? For example, if you have some term which is x minus 1 the whole square, it is repeating. Okay, x minus 1 is repeating 2 times. In that, these tricks will not, the tricks which I am going to explain will not work. As well as linear, it should be linear. For example, these are all linear because x raised to 1 over here. If you have something like 2x square minus 1, if you have any term which is non-linear, okay, then this trick is not acceptable. Okay. Now let's see. Now if you want to find x minus 1, okay, now you do one thing, you cancel this. Okay, you substitute, if you want to find x minus 1 term, you substitute x equals to 1 in this. Okay, in this. Okay, now if you substitute x equals to 1 in this, what will you get? You have 1 square upon 1 minus, okay, 1 minus 2 instead of x. Okay, here you have 1 minus 3. This is it's going to be your constant term. Okay, and then you have to integrate what? You have to integrate 1 by x minus 1 dx. Okay, plus, see now you put x equals to, substitute x equals to 2. Okay, when you put x equals to 2, you remove this. Okay, you substitute x equals to 2 in this equation. What you have? You have 2 square, 2 minus 1. Okay, 2 minus 1 is what? 2 minus 1 is 1. Okay, similarly here 1, you can say, you can write one step, 2 minus 1, and here 2 minus 3. Now this term you have to integrate. Okay, 1 upon x minus 2 dx plus. Okay, now x equals to 3. Okay, when x equals to 3 over here, you keep this 3 square, you have 3 square, and then 3 minus 1 and 3 minus 2. Now integral of this term. Okay, 1 upon x minus 3, okay, dx. Okay, now let's see. Okay, all this you have to add. Okay, this implies here 1 upon what? Here you have what you have is minus 1 minus 2 is minus 1. Okay, here minus 1, here we have minus 1 into here minus 2. Okay, minus 1 into minus 2 is what? You can have only 2. Okay, here 2. This is what? Log of x minus 1. Okay, plus here you have 2 to the 4. Here 2 minus 1 is what? 1. Okay, here 2 minus 3 is what? Minus 1. Here you can write only minus 1. Here minus 1. Integration of this is what? Log of, we have log of x minus 2. Okay, plus 3 3 is 9. 3 minus 1 is 2, 1. Okay, and log of x minus 3. Okay, this is same as, you can see, this is same as what? This is same as, you can check here, half log x minus 1 minus 4. 4 by minus 1 is same as minus 4 log of x minus 2. Okay, log of x minus 2. So it should be x minus 2. Okay, this should be x minus 2. Here 9 by 2 log of x minus 4. This is the shortest way, okay, to solve. If some entrance exam or some competitive exam, if they have given 1 mark, 2 or 2 mark or 3 marks, so you can solve. If you have to solve very quickly, this is the tricks which you can use. Be careful, these tricks are applicable only when all the denominator terms are non-repeated as well as linear. But keep in mind, it should be what? Proper function, means degree of denominator should be greater than, strictly greater than, same as 1. Here, okay, 0. Here you have x1, 1. You have 3, okay? You have 3, x cube. X cube is greater than x0. Okay, here 3 is greater than 0. And all terms are what? All terms are non-repeating as well as all are different, okay? Different terms, okay? Therefore, this is same as, I can write integration of this is same as 1 upon x into x minus 2, x minus 4 is equals to, I can choose some constant a with respect to x plus b with respect to x minus 2 plus c with respect to x minus 4. Okay, here I already assign a arbitrary constant x, okay, x, b upon x minus 2, c upon x minus 4. Similarly, okay, multiplying this, okay, x minus 2, x minus 4 on both side of equation 1. Okay, let's call this is equation 1. Okay, equation 1. Therefore, this whole term, okay, this whole term I am multiplying to this equation. Okay, now this term will get cancelled. What we'll have? We have only 1. Be careful. Okay, we have only 1. Okay, is equals to a into x. X gets cancelled. What we have? X minus 2, x minus 4 plus b. X minus 2 will get cancelled. We'll have x into x minus 4. We'll have x into x minus 4 plus c. X minus 4 will get cancelled. X into x minus 4. Okay. Now here, now if I substitute x equals to 2, okay, this term will go. Okay, whole this term and this term will go. So I will have values of c. Okay. Similarly, if I substitute x equals to 4, okay, this term and this term, x minus 2, x minus 2, let's do a into x here gets cancelled. X minus 2 is not there. X minus 4, it should be what? It should be x minus 2 actually. We'll have x minus 4 get cancelled. It should be x minus 2. Okay. Now let's substitute. Putting x equals to 2, we have, since there is constant term over here, okay, so we don't have to put anything into the x. So we have 1. Okay, we have 1 equals to, if I substitute x equals to 2 over here, this term, whole term will get 0 because 2 minus 2 is 0, and this term also will get 0. So I will have this b into 2 into 2 into minus 4 is what? We'll get minus 2. This implies 1 equals to, here 2 2s are 4 minus 4b. Therefore b equals to 1 by minus 1 by 4. Okay, this is your b. Okay, now if I substitute x equals to 4, so this term and this term will cancel, so I will get the values of c. on the left hand side, I don't have any x, therefore I don't have to substitute anything. So I will get 1 is equals to this term, and this term gets cancelled. So I will have this c into, I am substituting what x equals to 4. 4 into 4 minus 2 is 2. This implies 1 equals to 4 to the 8, 8c. Therefore, b equals to 1 by 8. So you have b. You have c. This is your c. Okay. So I want to get the values of a. Okay. I already have values of what? B and c. What I can do, if I substitute the values of x equals to 0, this term and this term will get 0, because 0 into anything is 0. 0 into anything is 0. Okay. So therefore, if I substitute x equals to 0, so 1 on the left hand side, 1. This term will get 0. Here a into 0 minus 2 is what? Minus 2. 0 minus 4 is minus 4. Okay, here 1 equals to 4 to the 8. A into 8, therefore a equals to 1 by 8. Otherwise, what we can do is, if I compare, okay, what is, I want to get the values of a, right? So x square. Here I will be getting a to x square, comparing coefficient of x square, okay? Here 0, otherwise what we can do is, comparing coefficient of, coefficient of x square. On the left hand side I have 0. On the right hand side I will get a. Okay, a, I will get x into x square I will get. Here also I will get b plus b. Okay, plus here also c. Okay, you have b and c, you add it and you will get the values of a also. Okay, this is somehow lengthy, so let's not do this way, because since we already get the values of a. Okay, substituting a, b, c's in this equation a, in this equation 1, and integrate it. Okay, therefore in this integral dx become, what is a? Your a is what? 1 by 8. Okay, 1 by 8 integral 1 by x dx, and then plus, okay, here b is minus 1 by 4, integral 1 upon x minus 2 dx, plus, what is c? C is 1 by 8, integral 1 upon x minus 4 dx. Okay, this is same as 1 by 8 log of x minus 1 by 4 log of x minus 2 plus 1 by 8 log of x minus 4 plus arbitrary constant. Okay, since it is indefinite integrals, just put some constant c. Okay, now this is same, but over here you have this is linear. Okay, the x square, x degree of denominator is 2 and degree of numerator is 1. Okay, let's solve. Okay, the fraction might come. Let's consider this x minus 5 upon 2x minus 3 into x minus 1 is equals to, let, okay, equals to a upon twice x minus 3 plus b upon x minus 1. Okay, so multiplying these on both sides, what we have is, we have x minus 5 is implies is equals to a into this, and this will get cancelled. We have x minus 1 plus b, x minus 1 gets cancelled. We have x twice x minus 3. Okay, now if you put x, if substitute x equals to 1, you will get b. Okay, value of b. Now if you substitute, what is this? Okay, let's see, substitute when x equals to 1 in this equation. Okay, let's call this is equation 1. what do we have on the left hand side? 1 minus 5, okay, is minus 4 is equals to a, this term will get 0 because x equals to, I am substituting the values of x equals to 1 into b. Here 2 into 1, okay, 2 into 1 is 2, minus 3, okay. Here you have 2 minus 3 is minus 1, okay. Here minus minus gets cancelled, you have 4 equals to b. 1 into b into 1 is b, minus 4, minus minus gets cancelled, you have 4, b equals to 4, okay. Now look at here, okay, you have twice x minus 3, okay. You have twice x minus 3. Let's see, okay, what is value? What will be values of x? If you substitute values of x, then you will get what? 0, okay. Now twice x equals to what? 3. Then x equals to 3 by 2, okay. Now if I substitute x equals to 3 by 2, 3 by 2, okay, let's see here. If I substitute x equals to 3 by 2, 2 into 3 by 2 minus 3. 2 gets cancelled, 3 minus 3 become a 0, okay. Therefore these terms will be a 0. So when x equals to 3 by 2, so what? 3 by 2 minus 5 is equals to, these terms get 0, a into 3 by 2 minus 1, okay, is implies, take LCM, okay. Here we have 2, okay, 5 to the 10, okay, 3 minus 10 is equals to a, here 3 minus 2 upon 2, okay. These 2 and these 2 gets cancelled, these 2 and these 2 gets cancelled. What we'll have is, you'll have here is minus 7 equals to, here a into 3 into 3 minus 2 is 1, okay. Therefore a become a minus 7. So we have values of a and b substitute over here, okay. So therefore integral, this, what is a? A is what? Minus 7, 1 upon 2x minus 3 dx plus, what is b? B is what? 4, okay. 4 upon, you can say take 4 outside, integral 1 upon x minus 1 dx, okay. Now here is, for this term, if you differentiate x minus 1, you are getting 1. Therefore this term is what? You have, this integral is, you have 4 into log of x minus 1, okay. But for this term, okay, for this term, if you differentiate this, okay, if you differentiate denominator for this term, you have differentiation of twice x what? 2, okay, minus 0. So you need 2, okay. So you need to get denominator 2 here, okay, 2 here, but these 2 is extra, so I can cancel with these 2. I need these 2 and these 2 gets cancelled. Why I'm putting keeping 2 over here? Because this differentiation of twice x minus 3 is 2, okay. I need these 2, but these 2 is extra, so these 2 and these 2 will get cancelled, okay. Therefore it's minus 7 by 2 log of twice x minus 3 plus 4 log of x minus 1 plus constant, okay. Look at here, okay. Now here in numerator, what we have is sine of 2xx, okay. The angles are different, okay. Here sine of twice x, here sine of x and sine of x, okay. Now you try to break this angle, okay. What is sine of twice x? Sine twice x is what? 2 sine x into cos x. What we have? Sine of twice x equals to 2 sine x into cos x, okay. Now these twice x become x in x and x, okay. So let's try in that way. After that, we need to substitute. We need to by substituting by algebraic, and you bring back to algebra, and so that we can do by partial fraction, okay. Now let's see. Sine twice x is same as 2 sine x into cos x upon 1 plus sine x into 2 plus sine x, okay, here dx. Now if I substitute, okay, if I substitute t equals to what? Sine x. Okay, if I substitute, why I am substituting sine? Because if all signs are there, if I differentiate sine, I will get cos x dx, okay. Therefore, dt will be what? Cos of x dx, okay. This dt, cos of x dx, I will be getting as a dt, okay. Here, I will be getting as dt, okay. Therefore, these two I can send outside here to sin x. What is sin x? T, okay. Here you can say put, okay. Here t upon t into cos x dx is what? Dt, okay. Dt upon 1 plus t into 2 plus t, okay. This is same as, consider, this is same as a upon, if I consider this is same as a upon, let's take 2 outside for time being, okay. Here I am keeping 2 outside. This integration is same as, let's say, a upon, or you can say, consider t upon 1 plus t 2 plus t is equals to a upon, here this is linear as well as non-repeated, so it is a proper fraction, so I can assign 1 plus t plus b upon 2 plus t, okay. Now multiplying this on both sides, what we have t equals to a into 2 plus t plus b into 1 plus t, okay. Now substitute, okay, so putting t equals to minus 1, okay. If I put t equals to minus 1, okay, this term will get 0. Therefore on the left hand side, what we have, minus 1 equals to a into minus 1, okay. Here 2 minus 1 is 1, okay. Here instead of t I am putting minus 1, okay. Here 2 minus 1 is 1, okay. Therefore I am getting a equals to what? Minus 1. Now if I substitute t equals to minus 2, okay, here I will have minus 2 equals to this is 0, minus 2 1 plus, here b into 1 minus 2, this implies minus 2 equals to minus b, okay, because minus 1 gets cancel, b equals to what? 2, okay. Here I am having a equals to 1, b equals to 2. Now we have the values of a and b, okay. Substituting this a and b over here, okay. After that we need to integrate, okay. Here if we substitute, what is a? A is what? Minus 1, okay. Here if I substitute, here a is minus 1 and b is what? 2, okay. Here 2. Now integration of this is same as integration of this, okay. Here with respect to t, okay. Here t, here I will be getting, this is same as, now differentiation of this with respect to t is what? 1, okay. Here minus 1 I can take common, here I have log of 1 plus t plus, here I can take 2 outside, here differentiation of this is what? Same as 1, okay. Therefore that is log of 2 plus t, okay, plus some constant c. Now here, what is t? You have to come back, okay. What t is what? Sin x, okay. This same as minus log of 1 plus sin of x plus 2 log of 2 plus sin x plus c, okay. This is the required answer for this, okay. Now question 5. Now question 5 is that cos x upon 1 plus sin x into 2 plus sin x. This is somehow similar with respect to 4, okay. Let's see what is upon cos of x dx upon 1 plus sin of x into 2 plus sine of x. Okay. Now here if I substitute t equals to sine of x, okay. Now if I substitute t equals sine x, then I will be getting what? Differentiation of t means dt is what? Is differentiation of sine is cos of x dx. Okay. Now cos of x dx, this term, okay, I am getting as a dt. Okay. Therefore this is same as dt upon 1 plus sine x is what? 1 plus t and 2 plus t. Now let's consider this. Okay. This implies, let's consider 1 upon 1 plus t 2 plus t is equals to a upon what we will have 1 plus t plus b upon 2 plus t. Okay. Multiplying this on both sides, what we have is implies equals to 1 is equals to a into 1 plus t will get cancelled. Here 2 plus t plus b into 2 plus t and 2 plus t will get cancelled. 1 plus t. Okay. Now if I substitute, or you can say putting t equals to what? In order to get this, t equals to minus 2 in this equation. Okay. So on the left hand side, what we have? Constant. Here 1 is equals to, this is 0, b into here 1 minus 2 is minus 1. Here 1 equals to, here 1 minus 2 is what? Minus 1. Okay, here b equals to minus 1. We have b. Now if I substitute t equals to what? Minus 1. Here we have left hand side 1 is equals to, this term will get 0. Okay, this term will get 0. I will be getting values of a. Here a 2 minus 1. Okay, is implies 2 minus 1 is 1. Therefore a equals to 1. So I am having a and value of b and substitute over here. So therefore this integral is, what is a? 1 upon 1 plus t dt. Okay, plus integral b is what? Minus. So let's keep minus 1 upon 2 plus t dt. Okay, this is same as, this is log. Okay, log of 1 plus t minus log of 2 plus t plus some constant, and instead of t, what is sine x? Okay, so you just write, instead of t, sine of x, instead of t you write sine of x. This is the required answer. Okay.